Okay, I'm going to put my mug up here. We're in the phase. Should have stopped at this point and just made it a mini lesson, like 13, and then mini lesson 14, and then put all this together into. We're just making it all exercise 9. So just hang in there, and we'll get through this. All right. It won't be that hard once we go get into extra videos there. The ones that are the ones that are highlighted. So I put that in front of my. In red are the ones that. Uh, that have information for you to help you answer the questions, and the ones that aren't highlighted in red, those are just fun to watch. Most of them are under 2 minutes. The William Trubridge and Tanya Streeter one, where they're doing the deep dive, which we're going to get into here, that one's a little oh well, but it's really cool for a journalist who's doing that report. He died in a car wreck just a few months after that. He's a great guy reporter. So anyway, of course, I like 60 Minutes. I'm old, but I think it's still a good show. Anyway, what I think is a total waste of time is CBS This Morning. All right, I'm sorry. That is too much of a geezer pleaser. That's what I call it. My wife hates it when I say that, but it is. It's a geezer pleaser. All right, let's go. Let's play from the current slide. Here we go. All right. Tennis balls put tennis balls in a high pressure. So in other words, you can revive them here, and over time the air seeps back into the ball, increasing the pressure. Because when we go up to a bicycle tire, we go, oh, it's flat. It's not flat. It is flat, but or we'll say, oh, it's flat. It must have a hole in it. It doesn't have a hole in it. It's just sat for a while without being pumped up, and the air's all seeped out of it. You might think, oh, but it does. It's got a bunch of micro little holes in it where the air slowly but surely seeps out. So you've got to put air in your tires all the time because the air will slowly find its way out. It just do what air do. Okay? Water does the same thing. What are we talking about here? Pressure. What is it due to? All right? Pressure's just like, oh, this one always cracks me up because it looks like this guy's taking a leak. No, this is a different one. All right, good. So this is one. All right, so pressure is equal to the density of the liquid or gas times the weight of gravity here on Earth times h. And if the atmosphere is 10 kilometers high, now you're going to find out that 10 kilometers is 10,000 meters. He was way above 10,000 meters, so he was well above. When Felix Baumgartner did that jump, he was well above the air. Okay, he was way above the atmosphere. In fact, you could see the curvature of the Earth. That was so cool. I just love that. But anyway, so the air pressure that we feel is in pascals, and it's 117. It's about the actual atmospheric pressure is this, and it's caused by the weight of the fluid that's on top of us. And it has everything to do with the density times gravity times the height of it. That has nothing to do with how wide it is. Okay? And that's about 15. So if you look right now, how many pounds smashing on your finger right now? About 15 pounds per square inch. That's one of your questions. This is our vacuum cannon that we have. We don't have good tape right now. You need this really strong industrial tape that we're having a hard time locating and getting. But anyway, you tape this end, well, put a ping pong ball in there, tape the two ends, bang! This is a vacuum pump, takes the air out, okay, pushes the air out, and then you fire it and it'll go right through that ping pong ball will go right through a Coke can if it's held stable. It's really cool. I wonder if we've got this. Oh, I don't have this. I wish I did. About 1,000 frames, and you see it go right in there. Maybe I just didn't wait long enough. No, I wish I had it in there, but I don't. So, in other words, you got 15 pounds smashed out here, 0 pounds here. Doesn't work. I do have a video of this. Watch this. Boom. They forgot to vent the rail car when they were sucking the fuel out of it. So that's what will happen. You forget to vent the fuel car. Okay? Yeah, there I am with us. That's us working on this. All right? And that's what it looks like. Because the outside air, 15 pounds, that's like a bowling ball smashing down on you everywhere, on every square inch of your body. It's huge. Okay, pressure in a can. I don't have the video here. I should probably get rid of that. But go watch the Steve Spangler science thing, and then watch the kids with the big 55-gallon drum. Both the videos are only like 3 minutes long, each one of them total. And why does the can get crushed? The metals quickly cool. The pressure inside the can decreased. The pressure inside the can decreased because we put a little water in here. It's a little water, and we start boiling it. And so what's going on? The bubbles are taking the air out of the can. So the pressure in the can, there's a huge difference in the pressure in the can. So when you put it in the water, notice he said turn it upside down. So you have to turn it, when you turn it upside down, that keeps the air from getting back in it when it's still boiling. Turn it upside down, boom, it crushes. Before, you boil it away. After, there's nothing there and it gets crushed. Water is extremely heavy. Water is extremely heavy. Look at that, 98,000 kilopascals. All right, 98,000 times. Well, it's 1,000 times air. It is almost 1,000 times heavy, more pressure than air. Okay, and this is and also, but it doesn't take much. This is why your tympanic membrane here, exterior, going up and down in fluid, air, water will vary the fluid pressure on the eardrum. This is why when you go way up in the air in an airplane, the pressure inside your head stays the same. The pressure outside is less. So it's actually not pushing in. It's actually a pain that's pushing out, and that's what makes it hard. Diving and snorkeling, same thing. The underwater breathing apparatus, what that does is that pushes air into your lungs. All right, you get air pushed into your lungs. Okay, instead of using scuba gear, we go deep. Could we go underwater using a long snorkel? The answer is, as we go under the water, the pressure increases the water above us. Okay, so we've got the pressure on the air surface, which is 1 atmosphere. Then if we go down to 10 meters below water, it increases another atmosphere, so it doubles. The air pressure actually doubles. For every 10 meters, we gain an atmosphere, and it doesn't have anything to do with how long, shallow lake, a dam of a deep lake, no matter how long it is, needs to have a thicker wall. The dam with it, what must be stronger? Okay. Oh, did I not answer this question back here? You can't do it. And the reason you can't do it, we're going to get to that. Snorkeling limits. He's retired now. This is Dr. Roble, and this is Dr. Kruger down here, and he's now the Dean of Arts and Sciences at South Dakota State University, and he's trying to breathe just through the snorkel, and as he got down to about 70 centimeters, he couldn't breathe anymore. The pressure was too large to inhale. Okay, and this is what a diaphragm does. All right, it takes the air in, and then it pushes the air out. All right, your diaphragm. This is as this diaphragm goes down, it increases the volume. All right, it increases the volume, which decreases the pressure in here, so the air comes in through your lungs, and then the air fills this up. The air comes in through this small hole. So that's what your diaphragm does. And then when you lower it, the air changes the volume, so the pressure gets greater and it pushes it out. Scuba regulator basically pushes air into you. All right. Decompression sickness. This is all kind of cool stuff. None of this is on your thing, so we'll just go. Basically, what happens if you ascend too quickly, the nitrogen gas bubbles in you. The nitrogen bubbles up. Basically, your blood starts to boil. and it causes the bends, and it really, really hurts. So to reduce it, ascend slowly. Don't use nitrogen. Use oxygen and helium combination. And this is what's in a oxygen tank for scuba diving. What about the air you breathe? 70% of it's nitrogen. So they put a little bit of helium in there and some oxygen. Okay? All right. And that's how you prevent the bends. Let's stop there.